Hello, welcome everyone. Today's webinar is about the importance of odor testing in polymers and coatings industry. I am Carmen Villatoro, Senior Consultant at Sensenet for 7 years now, and I am hosting this webinar today. I'll be happy to answer any questions. Please drop your queries to the email address is being shown, and we will answer as soon as possible. You can always register for a free 15 minutes one-to-one meeting with our expert, so we can answer your question or see how we could better help you in your projects. You just need to go on our website and select an available time slot that best suits you on the registration page. So let's start. As you may be aware of, polymeric packaging are found in many objects. It is used in plastic films, food containers, plastic furniture, bottles and toys, and others. Odor is an important factor in the polymer industry. Some questions in the polymer industry are: which chemical compound is causing of odor? How is the odor of my product compared to others in the market? Is my new formulation product causing less perceptible odor? There is a migration of notes into the product. What is an odor? Odor are a group of volatile organic compounds able to produce a sensory stimuli. Some characteristics. Most belong to volatile organic compounds. Relatively small molecules, less than 300 daltons. Odor can be referred to a complex mixture of VOCs or to a description of individual sensory perception. Odors show different threshold values, and depending on its concentration in the air, it can be perceived or not, or it can change the sensory perception. Now we are having a closer look into the chemical analysis of odors. The usual and robust methodology to identify odor molecules is through the gas chromatography with chemical detectors, mass spectrometer, flame ionization detector, time of flight mass spectrometer, and others. The suitability of the detectors in odor analysis will depend on the analytical needs. Gas chromatography mass spectrometer are able to identify chemically the volatile compounds related to odors, but they don't provide information about if the compounds smell or not, the odor description, relative intensity of each odor perceived in the sample. Regarding to odor threshold values, OTV, this is one of the most important parameters because it's the lowest concentration of a substance that can be detected by the human nose. This graph represents the odor threshold values of chemical compounds grouped by families. If we look at the axis on the right, we can see the sensitivity of the different measuring instruments. The most sensitive detector is the one that includes the human nose as a detector, capable of smelling below the detection limit of any instrumental detector. We highlight the GC time-of-flight mass spectrometer, capable of detecting compounds at sub-ppt levels. For example, some sulfur compounds with OTB values at ppb or ppt levels can only be detected with high sensitivity instruments, such as the GC olfaction or time-of-flight mass spectrometer. What about GC sniffing or olfaction technique? It helps to identify and quantify the concentration of the volatile organic compounds that can be released from a product, and at the same time, because it is highly trained assessors involved in the analysis, it can also identify the compounds from this list are relevant in terms of odor perception, and in more particular, in terms of generating an off-note on the final product. How it works? We have a gas chromatograph and we inject the molecules. The flow continues to the chemical detector and split again, and part of the flow goes to a human nose. The sniffer is describing the odor intensity and the odor character, and at the same time, the chemical detector is identifying the molecules. And later on, we put this information together and see which compounds are the more relevant for this product. As soon as the assessor detects an odor, odor intensity values from 1 to 5 and odor character are assigned. The smelling task was performed by two sniffers at room temperature and isolated for any distractions. During the analysis, each sniffer carried out the GC sniffing task for 15 minutes before giving way to the other sniffer, to cover the 48 minutes of the whole chromatographic process. In this way, the sniffing task is divided in 3 periods covering the entire chromatogram. Each sniffer covered all chromatography run twice. Therefore, 4 sample injections were necessary to analyze each sample. This is what it looks like in reality. One of the sniffers is smelling while the other is noting the required information of odor intensity and odor character. We use our nose in the analytical process. The reason for that our nose is still more sensitive than any analytical tool available in the market. It helps us to identify smells, even if there is only noise in the analytical outputs. There are others that smell with a low chromatographic signal, like the example of human odor. This is because the responsible odorant has a very low odor detection threshold. In contrast, for a detected metal odor, the concentration of the responsible odorant must exceed its olfactory perception threshold, which in this case is high. The identification of odors is a complex task and presents some difficulties. Stereoisomers presence, molecules that are the mirror image of another. Although they have an almost identical structure, they can smell different. A peak appears with almost identical molecular information, both appearing at the same chromatographic peak. For these cases, the most sensitive detector on the market are required, such as the time-of-flight mass spectrometer. Now, let's start with some case studies related to polymer industry. Case study 1 is about determination of other relevant compounds in polyamide samples by TDGC time-of-flight mass spectrometer sniffing analysis. The challenge of this study was other relevant compounds identification in different polyamides quality. For that purpose, samples were hauled into a microchamber during a period of 20 minutes at 230 degrees in order to ensure that of the volatilization of the more relevant compounds was produced. A 10x tube is then placed to collect the generate volatiles in the headspace and ready for GCMS sniffing analysis. For that purpose, the GC sniffing analysis focus on identify the VOCs compounds that have been released by this particular product. The sniffing graph shows the sensory profile of the 3 polyamides studied. Sample 2 and sample 3 show higher odor intensity for chemical, plastic and petrol, and putrid and cheesy olfactory notes. The table on the right shows some of the more relevant odorants that have been smelled in the polyamide samples. Some of the perceived odor have intensities of 4, considered a strong odor. Sample 2 and sample 3 have been the highest number of compounds identified with another intensity of 4. For example, key odorants table show that benzyl chloride and pegresol were smelled with intensity 4, strong, in 2 of the samples. These compounds were smelled with olfactory notes to sulfur var and phenolic floral respectively. Case study 2 deals with the study on off-note identification in coating samples by GC sniffing MS analysis. The objective was to identify the source of malodor from different coatings formulation. This flexible packaging is used in food sector. Two batches of coatings, control and experimental, were housed in the microchambers during 20 minutes at 70 degrees. The generated headspace was extracted into absorption tubes for further analysis. Amid volatile organic compounds were identified, quantified, and sensory characterized by means of GC sniffing MS. For that purpose, samples were hauled into a microchamber during a period of 20 minutes at 70 degrees in order to ensure that the volatilization of the more relevant compound was produced. A Tennant's tube is then placed to collect the generated volatiles in the headspace and ready for the GCMS sniffing analysis. These graphs show the concentration of each chemical group. Differences in some chemical compounds were detected in the reference sample with respect to the experimental sample, especially in aldehydes, organic acids, and heterogroups. The sensory profile shows that sample presents a slightly toasty character with respect to the blank sample. On the other hand, the blank sample stands out for its plastic rubber, floral sweet, and spicy salty olfactory notes. The main responsible for the off notes in sample were pegresol and hexanoic acid. We come to the end of this webinar. I thank you for your time and attention. I hope you have found it interesting. Please, for any questions, don't hesitate to contact me by email or directly with our offices. Please send any question you may have and we will respond promptly. Don't forget that you can always register for a free 15-minute one-to-one meeting with our experts to see how we could better help you in your projects. Just go on our website and select an available time slot that best suits you. Thank you very much for your participation.